Welcome guys to the best math channel in the world once again. Say on Busy Made It Easy channel. The only channel exam fears when it comes to mathematics. This is where we make math simple and fun for everybody to understand. We are here once again. If today is your first time seeing us, don't forget to hit the subscribe button, the like, comment, and share for all students preparing for any form of examination. You also have a benefit of those of you preparing to write mathematics exam can send me a DM and we'll see how best I'm going to assist you to pass the exam. So don't forget to subscribe, share to all students at all levels, from the basic school to the tertiary level, for them to understand mathematics principle. We are continuing our lessons on binary operations, and this will be the last lesson we are going to have on binary operations. And today's on, we are going to talk about, we've spoken about the commutative property and the closure property, and the video is available. There are many short videos that are selected past questions that I've solved step by step. You can watch and also practice more. And I've told you to know mathematics is about constant practice. Practice more and you'll be good. If you see any question, try to solve. Learn always and you'll be okay. So the closure and the commutative property has been treated. Today we are going to talk about the associative. The associative and distributive property of binary operations. We are going to talk about the associative and the distributive property on binary operations. But we are going to start with the associative property. We are going to start with associative property. Yes. So what does associative property say? We are going to start with associative property. The associative property, what does it say? So the associative property under binary operation means that the grouping of any element does not change the results. The grouping of any element does not change the results. So let's say three elements. Let's have three elements, A, B, and C. If I group them, the result shouldn't change. Yes, the grouping of this element does not change the result. This is what I mean. So if I have A, operation bracket, open B, operation bracket, C, bracket close, they are saying it should be the same. It's the same as B, operation A, in the bracket, operation C. Yes, the associative for that's what it means. So when you group three elements like this, this operation should be the same. If you don't get a different answer, that one does not qualify to be the associative property. Yes, or when you see A, let me use different operation B, operation C outside. It should be the same as A outside operation B, operation C, bracket close. Yes, I'm going to prove that. So under the associative property, this is the meaning of that. Yes, the grouping of the element, yes, using the operation does not change the answer or the result. Aside operation, in the normal numbers, if I have A plus B plus C should be equal to B plus A plus C in the bracket. What you need to understand is that addition and multiplication are associative. Yes, addition and multiplication are associative. As commutative, as they being commutative, they are also associative. And I'm going to prove that. So this is addition. So if I have A times B times C, it should be equal to B times A times C. Yes, this is what associative property says. So sometimes in objectives, you see, they will write this and they'll ask you what property is this. So when you see anything in this form, it is associative property that you need to understand. Yes, this is the associative property. Yes, this is associative property. For the distributive and the commutative and the closure property, I've explained that. You can go and check and understand this property of number. It doesn't only apply in binary operation. In sets, the properties of numbers are also applied there. So you'll be asked to list some elements in some set. Then you ask you to compare. Yes. So when you compare, you state whether the property is associative, commutative, or distributive. Yes. So with the associative property, this is how it is. So I'm going to prove using the addition or proving that addition is what? Is associative. Yes, I'm going to prove to show that addition is associative. So keep watching as I prove that. But addition is associative. So if I have the operation A, operation B, operation C, I'm saying it should be the same as A out in bracket B, operation C. So it means that if I have A plus B plus C is equal to A plus B bracket open C. So let's say A is 2, B is 3, and C is 4. So I'm going to prove that. So let's say A is 2, B is 3, and C is 4. So with the first one, I'll have 2 plus 3 plus 4. Then I'll have A out 3 plus 4. Now bracket first. 2 plus 3 is 5 plus 4. Then A out, A is 4. Then 3 plus, A is 2. A is 2. So 3 plus 4 is 7. So 5 plus 4 is 9. Then 2 plus 7, 2 is 9. So this is a proof to that. So you can also use any thread digit to prove that. Yes, any thread digit to prove that. So when you see any combination like this, or any property stated like this, this is the associative property. So you can choose any thread digit you want to also prove that. So addition, prove that addition is what? Associative. So this is it. So you can use any thread digit to also prove that. So I said addition and multiplication are associative. So now watch as I prove using so let me prove that one here. Prove that multiplication is also associative. So let me use a different operation. So if I have m in bracket m operation n, then operation y should be equal to m out operation n, then operation y. So I've used different. So with the multiplication, if I have m times n times y, it should be equal to m times bracket n times y. So let me use 3 digits to prove that. So I will not use the same figure. So let me say m is 1, n is 4, then y is 5. Let me put them back in the bracket. So 1 times 4 times 5. It says it should be equal to the m 1 times n 4 times 5. So 1 times 4 is 4 times 5. Then I have 1 times 4 times 5 is 20. 4 times 5 is 20. Then 1 times 22 is 20. So this is a proof that multiplication is also associative. So any property quoted like this means that the property used here is the associative property. Yes, so we are going to apply that. We are going to apply that in binary operations. A given table will be drawn, then after that, they will ask you, state whether or not the table you see is associative or not, as we did for the commutative property. So keep watching, subscribe, like, and share as we continue our lesson. So proof, or the question says, let the operation be a binary operation on the set A012 defined by the table below. So the table has been drawn with a set operation. So determine whether the operation is associative or not. Here the table has been filled for you. So you have to determine whether this table is associative or not by using the operation. Yes, by using the operation. And what you need to understand that as we quoted the associative, said if you have A, operation B, or operation C, it should be equal to A, operation in brackets, B, operation C. So it means this left hand side will be equal to the right hand side, given any three digits you choose. So here, let's see. So you can pick any line. So we have 0, 1, 2 here. Then we have 1, 2, 0, 2, 0, 1. So let me pick the last one. So I'll say A is 2, B is 0, and C is 1. Yes, C is 1. So watch closely as I prove. So the first one, you can use either the addition or the multiplication. So we can try both of them. Yes, we can try both of them. Yes, we are going to try both of them. So since A is 2, we'll have 2 operation 0, 2 operation 0, or operation 1. Yes, which will be the same as A, which is 2 operation in brackets 0 operation 1. So we are going to do this according to the table. So according to the table, what do we have here? 2 operation 0. 2 operation 0, what do we get? 2 operation 0, what do we get? We get 2. Yes. Then operation 1. Follow close. I'm solving them together. So 2 operation 1, I got 2 operation 1. Sorry, 2 operation 0. You get 2 on the table. Then operation 1. Then here I have 2 out. Then 0 operation 1. 0 operation 1, 2 is 1. Yes, 0 operation 1, 2 is 1. So let me continue here. So now, according to the table, 2 operation 1 is what? 2 operation 1 is 0, equal to 2 operation 1 again. 2 operation 1 again. 2 operation 1 again. What is it? That one 2 is 0. Yes, so I've gotten the same thing. So I got 2 operation 1 here. Then I got 2 operation, I got 0 operation 1. 0 operation 1 is 1. So 2 operation 1 is 0. That's the left hand side. Then 2 operation 1 again, which is also 0. The right hand side. So I've gotten that. Yes, so I've gotten that. So the left hand side is equal to the right hand side. Now let's use another number. Yes, another 2 selected numbers. So let's say A. Let's say now A is 1, B is 2, and C is 0. So the same operation. So A, operation B, operation C, we are going to have A out, B operation C. Yes. So follow closely. So now A is 1 operation 2, operation 0, then A, I have 1, then I'll have 2, operation 0. So the left hand side should be equal to the right hand side. So 1 operation 2, bracket first, 1 operation 2 is what? 0. 1 operation 2 is 0. Then operation 0. So now I have 1, then 2 operation 0. 2 operation 0 is 2. 2 operation 0. Now 0 operation 0 is 0. Then 1 operation 2. 1 operation 2 is also what? 0. Yes, 1 operation 2 2 is 0. 1 operation 2 2, I've gotten 0. Here. So each 3 numbers you select, if you get the same answer using this property, it means that the table or the operation you have defined on the table is what? Is associative. So since the right hand side is equal to the left hand side, which is A operation B operation C, is the same as A out B operation C, you conclude say the binary operation is associative. You conclude by saying the binary operation is associative. So this is it. There will be questions, or there will be instances where the question will be given in this form. The table will be drawn for you. Sometimes they will define a binary operation for you. Yeah, they will define a binary operation for you to solve. You fill in the table, then they will ask you to determine whether or not the property here or the operation is either commutative, associative, or distributive. And this is how we solve it. Yes, this is how we solve it. And I know how I've taken my time. You are going to get it. We can go over, pause the video, then solve and see if you get the same answer as I've gotten. So this is how we prove the associative property on binary operation. Now we are moving to the distributive property. So keep watching as we prove that one too. If you haven't subscribed yet, subscribe, like, comment, and share for all students to have a benefit of this channel. So keep watching. The distributive property. This is when 3 sets or 3 members of a set are defined over 2 given operations. 2 given operations. Yes, in a form like, so this in the distributive, 2 operations will be given in this form. So let's say we have A operation B operation C bracket plus. We are saying that it should be the same as A operation B with the second operation combined A operation C. So this is what the distributive property says. So 3 given members or elements defined over 2 operations combined in this form. If the answer here gives the same answer here, it means the operation is what? Is distributive, or one operation is distributive over the other one. We can say this operation is distributive over the second one. So given questions, question will be given, then you will show or determine whether the operation they have given you is distributive over the other or not. So this one, the operation is going to be defined. So you will solve using the 2 different operations. Yes, then you determine whether one is distributive over the other. So we are quickly going to take a question on how to determine the distributive property under binary operations. So keep watching. The screen says 2 binary operations. The operations are defined as A operation B is equal to 2xy and A operation B is equal to A plus B plus 2 for all A and B, AB belonging to R. So we have to evaluate I for operation, bracket open, 5 operation 6, bracket close, then II, bracket open, for operation 5, bracket close, operation, bracket open, 4, operation 6, bracket close. So what can you say about I and II? Yes, what can you say about I and II? Looking at what they've given you. So the operations are given. Yes, the operation given A, operation B was given as 2xy, and A, operation B was given as A plus B plus 2. Yes, A plus B plus 2. So we have to evaluate I. So the I is for operation 6, II, so bracket open, for operation 5. Then we have this for operation 6. Now, how do we solve this? Now, looking at this, what can you see? How will you know what they are talking about? When you compare this to this, it is the distributive property they are asking you to demonstrate here, or they are demonstrating here. But the distributive property goes this way. So, as I said, if you have one operation, A operation, bracket open, B operation C, to be A operation B, then operation A operation C. So comparing this to this and this to this is a distributive property they're asking you to demonstrate. Now, how do you solve it? You solve it by anytime you see the operation like this, you apply this rule. And when you see this operation, you apply this rule. Operation, you apply this rule, and if you see this operation too, you apply this rule. So we are going to solve the first one. So let me write solutions here. So the first one, I, 4, 5, operation 6. So bracket first. So 5, operation 6. It means you are going to apply this. A plus B plus C. Yes, A plus B plus C. So our A is 5 and B is 6. So this one will give us 5 plus 6 plus 2. Yes, 5 plus 6 plus 2. So 5 plus 6 is 11. Plus 2 is 13. So in the bracket, we have gotten 13. So now we are going to have 4 operation 13, for which we are going to apply the 2xy. So 2 times x, which is 4, times y, which is 13. So 2xy. So now 2 times 4 is 12. And 12 times 13 is going to give us 104. It's going to give us 104. So we have gotten 104 for the I. 104 for the I. So now let's come to II. Follow closely, II. So II says for operation 5, or operation 4, operation 6. So here, the bracket here first. So 4, operation 5. We are going to apply this rule, which will be 2xy, which will be 2 times 4 times 5. 2, 4, 8. 8, 5 is 40. So the first bracket has given us 40. Yes, first bracket has given us 40. Now we have 4, operation 6. The same 2xy. So 2 times 4 times 6. So we are going to apply this one too. You solve the separate bracket using this rule. When you finish, then you combine them using this operation by applying this rule. So I've solved the first bracket, the second bracket. This is what I'm coming to. So 2 times 4 is 8. Yes. Then 8 times 6 is 48. 48. Now I've gotten these two. So I have to combine them using this operation. So now I have 40 operation 48, which is A plus B plus C. Now A is 40 plus B, 48, sorry, plus 2. The rule is plus 2, then plus 2. Now even this plus this is 50. 50 plus 40 will give us 90. Now I've gotten 90. Now when I use this principle, or when I use this operation, the 4, 5, 6, as compared to 4 operation, bracket will be 5 operation 6. I got 104, then I got 90. What does it tell us? It tells us that the operation is not distributive over the other one. This operation is not distributive over this one. Yes, if it is distributive means the answer we get here, we are supposed to get the same answer here. Yes, as simple as that. Like the one that we did with associative, that we got the same answer. Yes, so now they say, what can you say? So I. So that's I. What can you say about I? So the answers in I and I shows that, or means that, the operation is not, so this operation is not distributive over this operation. Yes, this operation is not distributive over this. As simple as that. Or you can also say that this operation, 4 operation 5 operation 6, is not equal to 4 operation 5 operation 4 operation 6. So you can conclude by saying this one too. So with a distributive, this is how the questions will be asked. So when the question is asked, you solve with a defined operation, then you compare the first operation to the second operation. You have to be careful. When they state a given rule or property of number, you should be able to understand it. Yes, you should know the commutative, the associative, and the distributive property. And this also applied in set. So the knowledge here, you can transfer it to anywhere you see the properties of number, being the commutative, the associative, and the distributive. So you can watch all the properties I've explained on this channel, then you know the difference between them. So this is how you solve this. And this is the end of the lesson on binary operation. It has been a long and interesting lesson. So if you are confused or you have forgotten something, there's a playlist. When you go to binary operations, you start watching the first lesson up to this point. So if this is your first time seeing us, don't forget to subscribe, like, share, and comment for everyone to also have a benefit of it. Watch out for another interesting lesson on this channel. Until we meet again, subscribe, and we say goodbye for now.